Hello, let's solve pips. It's time to play some dominoes. We'll start with the easy puzzle. Let's start solving, shall we? Okay, we need 3 of something, which could be zeros or twos. It won't be the zeros because then we won't be able to make the less than 2. So it'll have to be twos. I mean, my guess is that we'll put 2 twos here so that we can more easily, yeah, we need to do that actually, I think, so that we can make the less than 2. Well, no, I guess we could have made the less than 2 with the 0, 1 in a single. Oh, maybe we do have to. Maybe we do have to do that, actually. How do we make the 4 now? We need a total of 9. Maybe we don't. Maybe that's not the twos. Oh, we have 4. Sorry, we have 4 zeros. I didn't realize that. It is the zeros that go in the equivalence. Sorry about that. So the less than 2 is the 0, 1. Yeah, okay, right. And then the 5, no, this doesn't work because the 5 needs to be 2 separate dominoes. Sorry, this is not going well for the easy puzzle, is it? So this goes here. No, it doesn't. How does this work? Sorry, I'm blanking. This shouldn't be as difficult as I'm making it. I think this goes here, this goes here, and this goes here. Yeah, this is finally correct. Then we have the yes, this is right. Sorry. Yep, there we go. I mean, that's a good puzzle. I jumped to conclusions early on, and that was unwarranted, but there we go. That is how to solve it. We'll move on to the medium. Let's start solving today. Okay, so we need greater than 10 in 2, which is double 6 or 6, 5. We need to keep 3 cells under 4. Sorry, we need to keep 3 cells to 4 and a single cell under 4 is what I meant to say. Right. Is there somewhere we absolutely need to put a 0? Is there any way where a 0 is strictly required? Well, it won't go in the 2-sized 4 region because I don't think we have a 4. We don't. Okay, so the greater than 10 needs 6, 5 or 6, 6. It'll probably be 6, 5 because that's usually when they say greater than 10, they mean 11, but they might not. We don't know. That goes into a 9, which can have nothing lower than a 3. So something connects these that has a 3 or higher on one end and a 5 or higher on the other end. So it could be double 6 or it could be 6, 5. Those are the only options. What if it were double 6? That would make this one be a 3, which is only one of. So this is an easy thing to rule in or out because it's a bit constrained. So now this greater than 10 is a 5 or a 6. It can't be this 5 or 6 because that'll break the 4. So it's, oh, interesting. So it would have to have a 2 on it, which means there's a 2 coming out of it pointing into the 10. I don't think it could be this 2, 1 because I don't think we could make a 9 with what we have from anything. No, we couldn't. So it would have to be a 5 or a 6, which would mean the remaining cells would have to add up to 4 or 5. It's doable with this 2 and another 2, which would have to be this. This is looking actually plausible. No, it's not, though. It's not, because now we don't have enough 2s to make the 4. Is there a way of doing this that I missed? Oh, we could have a 6, 5 in here? Or 6, 2, I should say. Does that make any difference? No. Wait, no. I think I did something wrong here. Something 6 or 5 goes into the 4. It would have to be a 2 that goes in there. We need a 2 coming out of that. Can't be this 2, 1. It would have to be a 2, 5 or 2, 6. Up here, we'd be left with 5 or 4 in total. The greater than 4. Yeah, it would have to be a 2. So this other one would have to be a 2 or 3, which would also have to be a 2. So we need a 2 that connects to something that won't break the 4. So we've used 2 2s, another 1 or 2. I feel like there's just too many low digits being used at this point. Yeah, I think this doesn't work. Okay. So what if this is 6, 5? It could be in either order, though. It could be this way as well. No, actually, it couldn't be. It couldn't be. Because there's no 4 to put there. Interesting. Okay, that makes me wonder if I oversaw. I probably didn't see some possibility in what I was looking at before. Yeah, these are the only, the two that I've considered the only possibilities in general, because otherwise we don't have enough to fill either the 9 or the greater than 10. So this would then have to be this 3, 2. The greater than 10 would then need to be a 6, which would require this to be a 2. Then we'd have a 2 going into the 10, which I don't think could be, no, it couldn't be a 1. The 1 couldn't go into the 10 because then we can't make 9. So it'd have to be this 2, 5, which would mean now we have to make 5 up there, which is not possible. Okay, so I'm doing something fundamentally wrong here. I'm thinking about this in a wrong way. I'm not giving myself a thing that I need. Yeah, there's nothing that could make a combination of 9 here. That's simply impossible. Okay. So I need to go back to the other possibility and see what it is I missed. Sorry about that. Okay, if this were true, we would need a 3 here. That's the only way to finish it. The greater than 10 is a 5 or a 6. I guess I'll just try both and see what happens. I mean, it's either a 6 or a 5. Either one has a 2. We'll try the 6 first. I think this is more likely to be wrong, but I don't know. That could be a completely meaningless facile statement. 2 goes into a 5. We now need a, yeah, this just looks broken immediately because now the greater than 4 will just break the 10 right off the bat. So this would be 5, 2, then 2, 6. Now we need a 4 up there, which also breaks. Sorry, what am I missing here? Oh, sorry. I know what I'm missing. I'm missing making the greater than 10 in a single domino. That's obviously what's going on here. No, it's not, because then we can't make the 4. Oh no, what am I doing wrong? Because we don't have a double 2 or a 3, 1. This is just, some days I just comport myself terribly, and it's pretty embarrassing to be doing this on video, I have to say. Greater than 10. I mean, this feels like a well-constructed puzzle that I am absolutely botching. 5, 2. Yeah, in this situation, the only thing that works here is a 6. We now need to make 4 out of those, which we cannot. It's simply not possible. So the other one would be 6, 2. This, yeah, I mean, I've tried this a million times. It's not going to work. We would then have to put this here. We don't have any digits that add up to 5 in any combination. So that's just, oh no, we do. 5, 0. I didn't notice that. I'm sorry. That's how we solve this finally. Yeah. Okay. So then we need a 0 here. This is how it works. That was available ages ago. Sorry about that. I just didn't think of 5, 0 when I was trying to add things up to make the 10. Oof. Okay. There we go. That was the medium puzzle. I'm dreading now the hard, but let's try it and see how it goes. Oof. Okay. All right. We have a double 0 up there. We have 1s. We have another 0. We have lots of things spoken for. So how many zeros do we have? Actually, quite a few. 1, 2, 3, 4, 5. We have 7 zeros. Wow. We've got, at the very least, 3 spoken for. Okay. We have 2 1s spoken for. How many 1s do we have? 1, 2, 3, 4. 4 1s. But we also have places like this 2 region that can only have 1s and 0s in it. Or, no, it could have a 2 0, sorry. We have a 12, which must be 2 6s. Do we have a 6, 0 that could bridge that? Yes, we could do this. I mean, this would start forcing things if this were true. Let's just try this and see what happens. The 12 would then point 6, 1, which is actually also possible. Right. Okay. That you know what? I should consider our 5-sized equivalence region as well. We have 7 remaining zeros. I mean, that is plausible. It's not possible with ones, I don't think. No, it's not, especially with the one we're already using. But it wouldn't be anyway, I don't think. And then 2s, we don't have enough 2s. 3s, it might be. 1, 2, 3, 4. Yeah, we do have 5 3s. And I don't see any 3s obviously yet spoken for. So it could be 0s or 3s. 4s, we do have 5 4s, although we have a 4 spoken for. So we'd need 6. 1, 2, 3, 4. Yeah, it's not 4s. Could it be 5s? I don't think it's possible. No, and we have some spoken for. 6s, definitely not. Okay, so it's 0s or 3s. Right, so we'd have either a 1, 4, which we don't have, or a 1, 0 or 1, 3. We have both of those, actually. The 4 would then need to be a 4, 0 or a 4, 3. And we don't have a 4, 3, so it would need to be this 4, 0. It might not be this orientation, but something like that. We have a 5, 4 that could go there. Well, actually, let's see. Yeah, okay. This bottom region isn't really restricting things in terms of the geometry. Well, actually, let's consider this 3 region. So the 5-sized equivalence region is 0s or 3s. Yeah, I don't know that I have enough. Oh, you know what? If this is true, actually, well, no, sorry, it's not even a question of if this specific thing is true, but we have another 12 region of size 2 that must also be 2 6s. I hadn't really noticed that. So we have a 6, 5 and a 6, 4. The 6, 5 could, I mean, this is all speculation, but I'm just trying to sort of limit things. The 6, 5 could point down there. The 6, 4 could point up here. Well, actually, maybe that is how it would have to go. Because maybe this is actually all forced. Because what are the alternatives to this? Yeah, there aren't any. Because we don't have any double 6s, so they need to point in other directions. So this one points into the 1. This one could point across into the 6, 4. That is actually possible. And then the 6, 0 could point up into nothing. So there is a bit of optionality, but the 6, 1 is definitely correct. Do we then have a 0, 5? We do. Okay, so this route also actually works, up at least so far. Could we go, yeah, we could even go 6, 0 if this turns out to be zeros. I bet that's harder to achieve. We then need a 5 connecting to something that can make it 2. I think that breaks. That breaks at this point. It does. Yeah, so that's not possible. We can't point that 6 across that way. So it would need to point down into the 5, which we can do, or up into the 2, which we cannot do. So it does point down into the 5. I think so far these are correct. That seems okay to me. Oh, but I forget. Now I'm forgetting what I've tried. Did I try this 6, 0 pointing over here? Does that... Yeah, that's fine as well, because this other 6 could be anything. You know, it could be, it's pointing into nothing. So that could go there. We even have a 4, 5 that can go here. Right. Okay, we also need some, yeah, okay, never mind. I was going to say we need something from the zeros that points down into the 2. If we did have 5 zeros, how many zeros we'd be left with? 1, 2, 3, 4, 5, 6, always 7 total. We'd use all of them. That might not be possible, actually, then, because how would we make the 2? We'd need 2 1s. We don't have 2 1s in a single domino, which would mean they'd have to be pointing out elsewhere. But that would be into a 5. We don't have a 1, 5. And it's 5 in either direction, actually. So that's not possible. So it's not zeros in there, it's 3s. I think that must be true. Okay, that's useful. We have a double zero that could be here in theory, but I don't know if there's any way to think about that yet. Okay, so do we have a 1, 3? We do have a 1, 3. So this could be there. Do we have a 1, 4? We also have a 1, 4. So this could be there. If that were there, this might be tough because then we'd have to double the 3 here. We'd have no more opportunities for double 3s. Would that be possible? I think it would because we could put a 3, 2 here and a 3, 5 here. We don't have a 3, 5. Okay, I think that means that's not possible. So I think that means we need a 1, 3 pointing this way. And we know we have we need a 4, 3, which we don't have. Okay, so something here is wrong. I kind of forget when I started being more speculative about this stuff. I think it was with where these 6s could be pointing. Like, did we have yeah, we had a 6, 4 that could be pointing here, and a 0, 5 that could be pointing here. This is a tricky puzzle because there's very sort of complex interrelating optionality. What does that do? Right. I think I said we couldn't have a 1, 3 here because then we'd need a 4, 3, which we don't have. Yeah, that's true. So I think that does mean we still need the 1, 4, which would mean we'd need a double 3 here. Now, does this break anything? We'd need either double 3 and 2, 5 here, which we don't have, or we'd need a 3, 2 and a 3, 5. No, this doesn't work either. Okay, this is my worst, I think maybe my worst pips day of all time. I'm obviously missing some kind of option at some point along this chain. What if I should just start over, shouldn't I? Sorry about this. Is it true that this 5-sized equivalence region cannot be zeros? I think it is. 1, 2, 3, 4, 5, 6, 7. Because then all of our zeros would be spoken for between that and the 0 region up top. And we need at least one more down here. Okay, it can't be zeros. I shouldn't have considered that it could be zeros. So it is 3s. I do think it is 3s. It's right. So where does this 1 go? It can't go 1, 3 here because then we'd need double 6 in the 12, which we don't have. So the 1 is 1, 6. I shouldn't have gone more. I should have just stuck to what I know at the beginning. We have both 0, 6 and 0, 5, don't we? Yes. So that 0 could go either direction. What about this 6? Yeah, it could go 6, 0, as we just said. Could it go 6, 3? I don't think so. Could it go 6, 4? Yes. So this is 6, 4 or 6, 0. What about over in this 12? 6, 5 we have. 6, 2 we don't have. 6, 3 we don't have. 6, 6 we don't have. So I think that means it is definitely 6, 5. These I remember figuring out. This was definitely true. It's after this that there's an option. Right. Okay. 5, 0 we have. 5, 4 we have. 5 something very low. Well, yeah, we do have, because we have 5, 0, and we're no longer limited on our zeros. So this, for instance, is possible. But I think that's the only thing that would be possible in this direction. How's that then? We'd need a 2 here, which connects to a 0 or a 3 or a 4. We have lots of zeros still. In this case, if this were 0, if the 3-sized equivalence region were 0, we'd have 1, 2, 3, 4, 5, 6, 7 zeros, which I think is how many we had, or isn't it? 1, 2, 3, 4, 5, 6. Oh, no, we have 8. We have even more zeros. Oh, I might have miscounted the zeros, and that might have ruled it out from the middle segment erroneously. No, I don't think that's true, because we'd need 5 in the middle, 6, 7, 8, definitely. Plus, would we need another one for the 2? That's what I'm not sure about. Could we make the 2 without any zeros? We'd need a 1 connecting to, I don't know, I guess maybe the 0 if that's zeros, and then I guess another 1 connected to something else. That actually seems possible. Oh no. Maybe the middle section is zeros. I mean, if it is, zeros are very constrained. So maybe that's what I should try and prove or disprove now. Five, six, seven, 8. So the 2 would have to be made up of 2 1s. Do we have a 1, 5 to go across that way? I don't think we do. So it would have to be 1, 0 up here. Then we'd have 5, 4 or 5, 0, which we have both of. This couldn't be, okay, this 1 couldn't point down into the 0 in that case, so it'd have to point across into the 4. That is true. Now I think we would need, well, actually our double 0 would have to go up here because we're completely maxed out on zeros. That means this would have to duck down into the 6. I mean, it is very constrained, and this would have to go down into the 4. Maybe that means it's going to be right. We'd then have a 0, 5 and a 0, 2. Wow. No, this would have to be a 0, 5, which we've already used. Okay. I think that means we cannot use zeros in this large equivalence region. I think that's what that means. I think that means it needs to be 3s. I think that is true. So this is 1, 3 or 1, 4. We have both of those. This is 6, 3, which we don't have, 6, 4, which we do have, and 6, 0, which we do have. So this cell is double 3 or 3, 1, which both of which we have. This cell is 4, 1 or 4, 3 in some direction, which we don't have. We don't have a 4, 3. So it is 4, 1. I hope everything I've said is right this time. Well, I don't know if it is. We've got 4, 3, 4, 5, or 4, 6. 4, 6, and 4, 5. We do have 4, 5. If this were 4, 5, this would be 0, 6, and this would be double 3. That feels a bit tough, so I'm just going to look at that really quick. 4, 5, 0, 6, double 3. Now all of our other 3s would have to connect elsewhere, which I think just breaks immediately, because this would need to be 3, 5, which we don't have. So I don't think that's possible. So that 4, 5 is not viable. And I don't think I think I said we don't have a 4, 3. So it would have to be 4, 6. I think that must be, is this right? If it's not right, I don't know what I'm doing. This is 0, 5. This would still be double 3. Oh no, but that means we still need a 3, 5, which we don't have. So I am making a mistake. I am making a mistake. If the 3, 5 can never go this way, then the 3 needs to be internal or connect to a 4, which we also don't have, which would mean this would need to be here. So what am I missing? This is a catastrophe. Am I just going to have to give up on this? Is there another digit I'm not considering that could fill the 5 region? What am I missing here? What am I missing? This feels like a very tightly constrained puzzle that I am just absolutely failing, utterly and completely. We don't have a 4, 3. We don't have a 4, 3. So if this is... I mean, this 5 and the way these things all interact feels like the key. The 5 goes to 5, 2, or it goes inside to the middle. But we don't have a 5, 3. But we also, I don't know, we do have a 5, 0. Okay, if I strip this all back to the beginning, is there some way that this works with zeros? This would be 5, 0. I can't believe how silly I'm going to feel if this all actually works in this configuration. This would have to be a 2, 0 to maintain the kind of geometry up here. I think the double 0 needs to be up there in order to have enough zeros to keep going, doesn't it? Well, no, maybe not, because maybe I could do 2 1s in the 2. 0, 5 or 0, 6. We don't have a 0, 5. So 4, 5 or 4, 0. We don't have a 4, 0, so this would have to be 4, 5. This would be double 0 or 0, 3. It can't be 0, 3, so it'd have to be double. No, this doesn't work. This doesn't work. So maybe when I was putting, maybe the 4, 1 actually have to be together for this to work. Or it just doesn't work at all, and I was right before, and I've just been wrong about something else, which is totally possible. So these would have to be double 0. And this one would have to be the 0, 1 to make the 2. Oh, maybe this is how it works. I bet this is how it works. I can't believe how much I've fumbled this for so long. Why did I not see how this could work? Because now we need a double 1 to make the 2, but that's fine. Not, or 2 different ones, I guess is what I mean to say, which would be this. And now we need 3s to finish that. This is fine. This is fine. Now to make the 8, we need a 0, 4 here. We need our other 0 here. We need a 4. Yeah, this is fine. What did I do? Why did I miscount those zeros? How did I make that mistake? Oh, not my day. Not my day, is it? Well, those were the pips. I mean, I think this is a very good puzzle. I just made a complete mess of it. An absolute mess. Really just catastrophic mess. It was absolutely core, this 5-sized equivalence region, and I just blatantly misinterpreted whether it could be 0. All right, those are the pips. Sorry, back tomorrow. Bye for now.